All right, we are going to continue on just where we left off. Now we're going to start multiplying and simplifying things. So now, when we look at this first one here, I'm looking at 1/5 times 3/8. Now, the book will love to break everything into prime factorization and reduce if possible. And anything over itself is 1, and that's where it goes away. I will show both ways, but I like to look at common factors. Now, when I look at this, 3 and 5 have no common factors. And again, we're going to see if there's any common factor up and on the numerator and the denominator. Now, 1 and 8, 3 and 5 have nothing in common, so I just multiply across. 1 times 3 is 3, 5 times 8 is 40, and that's all I can do. Now, this one, 7 eighths and 7. Now, I like to reduce because 7s are both divisible by 7, 8s are divisible by that. So what I do is I draw 7. I'm going to divide each of these by 7, divide each of these by 8. Then I'm going to rewrite it. So it's 1 over 1 times 1 over 1. And well, anything over self is just 1, so my answer is 1. Now, if you type in 1 over 1, the computer is going to say, although it is correct, it is not in the right format. So you got to be careful on that. Alrighty, you just want to write the 1 without the fraction. Okay? Now this next one here, 4 over 1. Because 4 is not a fraction, I have to make it into a fraction. So I'm going to rewrite this a little neater here. 4 times 1 over 3 over 16. Now it is starting to do something weird on there. We'll see how long I can go there. Alrighty, so now let's do this. Now 1 and 3 have no common factors here, but 4 and 16, they're both divisible by 4. So I'm going to want to divide each one of those by 4. 4 divided by 4 is 1. Now 1 and 3 can't reduce, so I leave them the same. 16 divided by 4 is 4. So now, I have nothing else to reduce, so I just multiply straight across. 1 times 3 is 3, 1 times 4 is 4. Now, on a side note here, I'll write this over on the side here. So 4 over 1 times 3 over 16. What the computer will want you to do is break this into prime factorization. So 4 is really 2 times 2 over 1 times 3. Now 16, you'd have to break into 4s, and then 2, 2, 2, 2. So 1, 2, 3, 4. So then I can cancel 2's, 2's, 2's. Then I'm left with 3 over 4. They both work. The computer likes to show it this way. I like to do it the other way. Please feel free, whichever makes more sense to you. If you're getting them right and doing it properly, I'm good. Now 8/15 times 10/3. Now 8 and 3 has nothing in common, but 10 and 5, or 10 and 15, they're both divisible by 5. So again, the 8 and the 3 don't change, but 10 divided by 5 is 2, 15 divided by 5 is 3. So now we just multiply across. 8 times 2 is 16, 3 times 3 is 9, and we are good to go. Alrighties. So now, simplifying fractions. Again, this is very similar to what we were doing before. We're reducing. What do 4 and 6 have in common? Well, they're both divisible by 2, so divisible by that, so it's 2 over 3. Now again, what the book will do is they'll do 2 times 2 is the top, 2 times 3 is the bottom, the 2's cancel, and there's my 2/3. Now this next one, just thinking of a common factor is not the greatest, but I still think it's easier than doing the prime factorization of both of those numbers. I see they both end in 0, so I know they're both divisible by 10. 120 divided by 10 is 12. 220 divided is 22. Now I know they're both divisible by 2 because they're even, aren't they? So I can divide each by 2, and then I get 6 over 11. Now what I really should have seen is, really the common factor is 20, isn't it? 120 divided by 20 is 6. 220 divided by 20 is 11. But if you don't see the greatest common factor right away, you can do common factors till you get there. They're both perfectly fine way of doing it. Now at 72 over 63, we really got to notice that 9 is the common factor here. 72 divided by 9 is 8 sevenths, and that's all we got to do. And again, these are all in the multiplication chart. Use the multiplication chart. This one here, usually people get wrong the first time, or they make a silly mistake. Most people just don't understand what they want. If we're simplifying the ratio, this is a way of writing a fraction, but you really, if you write 15 over 80, now it makes more sense. This ends in a 5, this ends in 0. They are both divisible by 5. So get your multiplication chart. 15 divided by 5 is 3. 80 divided by 5 is 16. And there's my answer. Same thing here. 49 over 84. Now 49, only 7 goes into that. And if I look on my chart, I'll see they're both divisible by 7. So I get 7 over 12. And that's all you got to do. This next section is almost preparing you for 1B. They're trying to plant a seed here. If we want to write equivalent fractions here, so what I got to look at is 5 times what is 25. So I got to multiply the bottom by 5. Then I got to multiply the top by 5. 3 times 5 is 15, so the missing number is 15. But if you notice, it's equivalent because I'm multiplying by 5 over 5. 5 over 5 is really just multiplying by 1. Anything times 1 is itself. Now this next one, what we have to do is we got to change this into a fraction again. So it's 4 over 1. So 1 times what is 13? So I got to multiply the bottom by 13. So I got to multiply the top by 13. 4 times 13 is 52. All my card players know that by heart, that one. If you don't play cards, then yeah, that's not very helpful. Express the shaded region as a fraction. And then what is 2/3 of that shaded region? Well, here is the shaded region right here. That's 9 blocks. So it is 9 over, well, let's see, this is 5 this way, 4 down. 4 times 5 is 20, so it's 9 over 20. Now 2/3 of the shaded region. Of usually means multiplication. So if I want to do 2/3 of, which is multiplication, the shaded region is 9 over 20. Now, we're multiplying fractions again, but I want to reduce if possible. If I look at this, these are both divisible by 2. These are both divisible by 3. 2 divided by 2 is now 1. 3 divided by 1. 9 divided by 3. 20 divided by 2 is 10. So I get 3/10. Now, I do hope you like that better, because if I didn't reduce anything, I would do 2 times 9 is 18. 3 times 20 is 60. Then I would have to find the common factors to reduce down to there. If you can reduce first, it makes it so much nicer. All right, and they always love to throw in some word problems. Of course they do. So there are 4 word problems we're going to go over, and that'll be it. This might be even shorter than part 1A here. So we have 4/5 of a pound of truffles in a box. Okay, so how many pounds of truffles would be needed to fill 85 boxes? Okay, so let's say we had, let's make it simpler. Let's say there was 2 pounds in a box, and we wanted 5 boxes. So that means I would need 10 pounds to fill it up. So really, these are multiplication questions. And if you notice, we really only talked about multiplying this section, so that makes it a little bit easier. 4/5 times 85. Now I got to make 85 into a fraction, so I put it over 1. Now we should notice these are both ending in a 5 here, so they are both divisible by 5. So when I rewrite this now, this is 4 over 1 times. Now 85 divided by 5. Now we got to look it up on the multiplication chart. I don't have a multiplication chart here. So I want to make sure I get this right. I think it's 17. Yes, it is 17. So 17 over 1. Now I got to do 4 times 17. And again, this is on the multiplication chart. So just look at your multiplication chart. 4 times 17, and you get 68. So it's really 68 pounds of truffles. This next one here, we have 4/5 cups of flour. A chef is making an amount that is 5/7 of the recipe. So it is 5/7 of 4/5. Now remember, we just said of is multiplication, so again it's going to be multiplication here. So it's 5/7 times 4/5. And so from here, the 5's will cancel because they're both divisible by 5. So it's really now 1 over 7 times 4 over 1. So it's just 4/7. His student's tuition was $900. A loan was obtained 2/3 of the tuition. So it's 2/3 of, which is multiplication, the tuition, which is 900. Again, we put it over 1. Now again, this is a nice one. The zeros we can almost ignore. If I divide each of these by 3, the new question is going to be 2 over 1 times, now 9 divided by 3, just add the 0, so it's 300 over 1. 2 times 300 is $600. Okay. And this last one is kind of evil. I think they've taken it off the quiz again. But 1 out of 26 high school players play college, and then 1 out of 37 plays professional ball. What fraction of high school? So it's 1/26 of 1/37. And nothing reduces here, so that stinks. And we have to do, well, the top is super easy. 1 times 1 is 1. I can handle that. 37 times 26. 26 times 37. Occasionally we will have to do this, and I will walk you through one. Hopefully this does not happen often. It's bad luck if it does, but I do want to show you. So I got to start with 7 times 6. That's 2, carry the 4. 7 times 14. 14 plus 4 is 18, so that's 182 there. If I do now, when I start doing the 3, I have to put a 0 there, or put an X there. However you were taught, it's all correct. 3 times 6 is 18, so it's 8, and now we carry a 1. 3 times 2 is 6, 6 plus 1 is 7, so we get 7. Now I got to add those two together. 2 plus 0 is 2, 8 plus 8 is 6, carry the 1, 9. So this is 1 over 962. I hope that doesn't happen very often to you, but it does occasionally happen. And just as practice, this is totally unnecessary. I'm going to do it in red here, but I'm going to do 37 times 26. It really should end up being the same number. I'm just multiplying the same thing here. 6 times 7 is 42, so it's 2, carry the 4. 6 times 3 is 18. 18 plus 4 is 22. I put the 0 here. 2 times 7 is 4, carry the 1. 2 times 3 is 6 plus 1 is 7. 2 plus 0 is 2. 2 plus 4 is 6. 7 is 9. And I get the same answer either way. So it's slightly different, but I did want to show you both ways to give you a little extra practice. All right, and that's the end of 1A. So that was pretty good. Hopefully this will help you on the second part of the 1A homework, and I hope you find these helpful.